Hello, my name is Mark Elliott. I am the Chief Operating Officer of Electro Optics, and we are very pleased to be able to bring you today an interview with Elmar Elbinger, who is the Product Manager for Optics at Materion Optics, a company we've been interested in for some time and is doing some really interesting work. We wanted to talk generally about a range of products in the linear variable filters category. But first of all, Elmar, I'd like to just ask you a little bit about Materion Optics. Tell us about the company and what you do.
Yeah, Materion is a United States-based company. It's on the stock exchange in New York listed. And the company was founded in the 1930s. And I personally belongs to the optics part, to the optics group located in Germany, in the city of Jena. And I'm working here as a product manager since 13 years for this company.
Thank you. It's always really good to talk to people at the kind of coal face of this product development. So we're here today to talk about linear variable filters. Obviously, I want to understand what motivated the development and then subsequent launch of these filters.
Yeah, we got inquiries from customers, to be honest. So we are very strong with our products in the biomedicine applications, in analytical applications. And quite often we are faced with the problem that in the fluorescence technique, they use different types of filters. And they were looking for a better solution that they not use a bundle of different filters. And customer ask us if there is the possibility to develop a filter which can use for different medical applications, for different fluorophores in the fluorescence microscopy application, for example. And so we start thinking about if we can create a filter which is able not only one wavelength, which is able to realize the investigation of fluorophores for several wavelengths. And so we created a linear variable bandpass filter.
So it's always interesting when you hear companies being approached by customers about specific application needs. Was this something you were thinking about already? So did it fit within, kind of established planning and development ideas, or was it a completely new opportunity, I suppose, in terms of product development?
Yeah, we are always looking for new approach for new products. We are very driven by development. So we try to focus on what the customer needs, what is new on the market, because the mass of production we cannot handle, we are too expensive. But we are looking for dedicated applications. And then when we got this request for these types of filters, we start to development because this is really fits to our main business, what we do, creating optical components, optical filters. And then we started the development process for such type of filters based on what the customer needs. Yeah,
I understand. And what was this a market you were already kind of established in? Were you already working a lot with clients in the life sciences and medical area?
The market itself, I would say, is really new because these filters are a lot of companies. They ask us for such a solution. They said they never heard that such types of filters are existing.
Okay.
So, and from this point of view, this market is still new, and we try to develop to grow with the market. We try to do marketing for these products so that we develop a market also, and we want to show on, for example, on the laser show in Munich, we want to show what these filters can do for the customer.
Yes.
So we develop the market, we develop also the products. Yeah, that's our interest.
Yes. And how long did that product development take? I mean, from that first kind of customer feedback to when you had a prototype, how long was that kind of work cycle?
Yeah, when we did the first development, I would say that is 5 years ago, and it took us 2 years. Yeah, I would say it took us 2 years that we had the first types of filters running in the production. so that we were able to solve customers' applications. So it took around 2 years. And from this point of view, when we had a breakthrough in the development, in the process technology, control the process, from this point, I would say now we are able, if we get a request from customer, we are able to from the first idea to the real product into 8 to 10 weeks.
Wow. So this product development has really kind of accelerated your ability to turn around an idea into something practical that can be used. That's impressive. And obviously this kind of product works in a very regulated market. There's a lot of sensitivity about medical devices, etc. Did that regulatory challenge also have to go through quite a lot of rigorous assessment?
Yes, of course. The regulations are there, especially in this market. But we have seen that this filters is not only suitable for the biological application or in the medical industry. In the meantime, we also find applications like hyperspectral imaging, for example.
Yep. Okay.
We get interest from customers working in the hyperspectral imaging. For example, they have a sensor, and they want to have the sensor pixel different informations. So, and in the time before, they use striped filters or bandpass filters, different types of filters. And now the first customer came to us and they asked for a linear variable filter on top of their sensor system, so that each pixel of the sensor can use for different wavelengths. And this is really special or really interesting for companies working in the field of hyperspectral imaging, space application, space bomb application, for example. And yeah, we have also a customer who works in agriculture, who want to check what is on the field, on his farm, how many water is in how many dust water is in the air pollution. And so this is a typical application, and this market of application is growing.
So obviously this is what's interesting about these technologies. You get new inquiries about new opportunities based on people saying, oh, I like the idea of that. What could that do for me? So when you get that sort of inquiry, what are you able to tell new customers or prospective customers about the technology?
Yeah, when we get an inquiry from the customer, then we start discussing with him about his technology he uses right now. Typical, our customer they use had used before filters typical with a round shape, and the linear variable bandpass filter is a rectangular typical, because we have a lot of bandpass beside each other on the filter located. So we have to explain to them that they have to change their mechanical setup, for example. So then we define the size of the filters, the length, the width, and then what type of filters wavelength he needs on the filter. What is it a long pass, is a short pass, or band pass filters? What the customer have to explain to us in detail. What is his requirement? What information he want to get? He want to earn out of the filter. And then we start designing our mechanical toolings for the coding process itself, which is installed in the coding chamber then after, and then we can produce the filter for them. And in the meantime, I would say we have so many experience of building such types of filters. So we have only one run, and then the filter should be work typical. That's what we get out. Yeah.
And tell us about those runs. What sort of volumes are we talking about typically in a run that you're doing for these types of filters?
So we use a coding technology. It's called PARMS, Plasma Assistive Reactive Magnetron Sputtering Process. Yeah. And this machine, it's a sputtering process. That means you have a turntable in the machine, and we can equip this turntable on 10 different positions with filters. And so typical, we get out if you have depending on the filter size. You get out 100 to 200 of these filters out of one batch, one coding batch.
Okay.
No.
And how do you maintain consistency across so many filters? You know, are there issues around spectral performance and consistency?
This was indeed a hard work or a lot of years with a lot of experience we made in this time. We developed this process by controlling the machine so precisely. We found out that the key for a very good linear variable filter with a very high optical performance is the process control.
Right.
And then we put a lot of effort in the control of the process so that we can control very precise the coding process itself, the sputtering rate, the energy level, and so on inside of the machine. And so we have the chance to have a very high level of uniformity, for example. And this is one part is the coding, and the second part, what we had to develop during this time, is the metrology setup.
Yeah.
You can on one side you can produce these filters. On the other side, you must be able to show this performance by your own metrology setup. And we had to develop a completely new metrology setup for these types of filters.
Okay. Yes, and it's noted, isn't it, that these filters work well in more extreme environmental contexts.
Yes.
Would that be one example of somewhere where you think these have been transformative in terms of their application?
Yes, I would say yeah, because the sputtering process itself shows a big advantage.
Yeah.
For the uniformity and also for the environmental stability, of course, because it's a very hard coding technology. That means these filters are very stable from the optical performance. So they are space qualified, for example. We can use it in the space, and they can be really used under very harsh conditions on the field for the customers. Yeah.
And what do potential customers need to know about availability? And you talked a bit about how quickly products could be turned into from development ideas into actual production. But are there issues around limitations on the customization or certain geographies where, you know, there's a challenge in shipping? I mean, other than the obvious tariffs and, you know, all the logistics challenges that we're all aware of. What do customers need to know about wanting to investigate and then get to an order position?
Yeah. It's so that the coding technology we use, there are some advantages. For example, we can manufacture filters with a very high level of transmission of light, which is, for example, in the field of hyperspectral imaging is very important. In the fluorescence application, on the opposite of in the other fields of application, very deep blocking beside the bandpass area is needed. So customer have a request here for a high level of light blocking beside the bandpass where they want to have to measure the fluorophore, for example. And this high transmission or the high blocking level, this indeed is a cost driver for manufacturing. And this is what we discuss with customer in advance. For the customer, where we say, okay, here we can bring you up to a high level of transmission, 99%. But on the other side, blocking is it's much harder to do than in this field. And so we discuss with the customer the advantages of the filter and where are the limitations are. And this, depending on the customer need, quite often we can reduce their specs or we generate specification, filter specification in combination with our customers. Where we say, okay, if you want to save money, maybe we don't take care for a far infrared range on the filter. We focused more on high transmission in the bandpass area and the visible range, for example. And so we adapt our filters to the customer needs. And this is typical a process in discussion, which takes around 4 for weeks, I would say, depending on the customer. And then we need to have the production time.
And this is a question I often ask of everybody that I talk to in this sort of situation, which is, what advice would you give to somebody who was thinking about linear variable filters for the first time? What should they be thinking about? When should they approach you? And what do they need to consider before they even make the approach to a company like yourselves?
What a customer really has to know is, or what he have to think about, is really what kind of optical performance he's looking for.
Yeah.
So, what kind of spectral performance, or also from the substrate wise, from the substrate flatness, accuracy, the surface, the cleanliness of the surface. What is really neat? And sometimes they are looking for the best thing ever can get. They want to have all things together, which is not possible.
Yep.
We have to find out what is really needed for the application. Have the imaging system, they are looking for distance measurement, what we have in the semiconductor area, or they are looking for fluorophores, for example. So we have different needs. Sometimes you need the blocking, sometimes you need the transmission, sometimes the steep edges of a narrow bandpass filter don't need to be so narrow as the customer requested. So, and this is a cost driver, and we discussed this with them.
Okay. So what I'm hearing here is a need for everybody to prioritize what is really important in a project, and secondly, to perhaps be prepared to really think about those choices, because inevitably, as you said, everything that's required potentially adds cost, time, and further limitations on other usage. So no, that's good advice, Elmar. Thank you. And final thoughts. I mean, in terms of where this goes from here for Materion, obviously these products have made quite a splash in the market. We can see that already. But what's your prediction for how this product range, develops for you and for the users?
I think this will be a strong development for the next year in this field of linear variable filter. We were really surprised over the last 2-3 years how many inquiries we get, and now these filters getting smaller and smaller. More and more customers want to have a linear variable filter downsized to a sensor system to put it on top of a sensor system. So, and from this point of view, I see a strong development in the market for the future. And this makes me very happy for the next years. Yeah.
Good. Okay, it's good to hear. Well, thank you, Elmar. That's been a really interesting introduction to the product range. Obviously, we'll be keeping a close eye on it. Details of where to find further information about Materion Optics range of linear variable filters will be available at the end of this article. And we look forward to hearing from customers as well about their experiences with this really interesting product.